The topic for this one is sampling variability. So here I created some data for a few thousand people. For each person, they have some quantitative variable, which is usually around 200, and a categorical variable, everyone is an A or a B. And so we can summarize that with population parameters. We can calculate some stuff we've seen before, a mean or an average, a median, a max, standard deviation, and the proportion of A's. We could look at a distribution of the quantitative variable too. You see it's unimodal, but it's got a very strong right skew. In fact, the max of 275.2 is such a short bar it doesn't even show up here, but if we hover over it, it'll tell us there's a point. So the two things we look at the most in statistics are means and proportions. And so we need to start paying a little more attention to the notation for those. A population mean is referred to as mu, and a population proportion is referred to as lowercase p. So what we can do is we can now sample from that population. We can take a random sample of 10 people. My computer is very slow today for no good reason. But every time we do this, we get a different random sample. And we can calculate some sample statistics for both our size 10 and our size 250 people. And for some reason, they both change. Well, never mind. So if we calculate a sample mean, that is known as x bar, and you can see every time you take a random sample, the means change a little bit. We saw our population mean was 199.9. That's never going to change. That's the average for everyone in the population. But every sample mean is going to be different. They will sometimes be a little higher than 199.9, sometimes a little bit lower. Same thing with the population or the sample proportion known as p hat. And if you can't find this stuff on the keyboard, you just type out like x bar or p hat, like that is fine. Some people do one of these, which is fine. Everyone will understand what you mean. But you can see those jump around quite a bit. Now, the larger sample, the less they're going to jump around. You can see the sample proportion p hat is usually around 0.6, whereas in the population it was 0.597 is the proportion of people who are A's, and the sample proportion jumps around a little bit, 0.592, 0.588, 0.572, 0.608. So sometimes a little higher, sometimes a little lower. So the sample statistics will vary from sample to sample. So whenever you think about sampling variability, you want to think about doing multiple samples, like sampling over and over and over. And since those vary from sample to sample, we can talk about the distribution of either of these. Again, x bar and p hat are the most common. But since p hat differs from sample to sample, it has a standard deviation, and so does x bar, which starts to make things a little confusing because we have this population here with some numbers, and we have a sample proportion here which differs. So you start talking about the standard deviation of p hat, it starts to get a little more complicated. But let's use that as a segue into some specific examples of sampling variability.